Just a quick reminder, in case you took a little break yourself, this is the 4-host network we're going to use. And again, I am using Cisco routers for the host, so the pings will look a little different than they would if they came from a PC. But we're using the single IP subnet 10.110/24 to meet Cisco's best practice. And what we're going to do is configure the network so that a broadcast sent by host 1 is only forwarded to host 2 and vice versa. Hosts 3 and 4 should not see any broadcasts coming from hosts 1 and 2. Now, I did use ping to test connectivity before we went back on camera, but I'm going to do it again here just from host 1. And you can see that we can take care of business. We can ping all of those other devices. We've got connectivity throughout the network. Now we will go over to the switch. And one more thing you want to verify. Just before you start a lab, just make sure that your ports are in the VLANs you expect them to be in. And here we expect them to be in the default. Nothing has changed. And we are ready to go. We're going to put ports 1 and 2, technically fast Ethernet 0/1, but I'm not going to say that every time. It's going to be easier on me and your ears to just call them ports 1 and 2. Now I'm going to put ports 1 and 2 into VLAN 12. That's just a little organizational tool I like to use because I can look at that later in a small lab or large one and say, okay, VLAN 12, I know ports 1 and 2 should be in there. It's not a requirement, but it's just a good organizational tool for you to get in the habit of using, especially if you're looking at the IE down the road. You want all the organizational tools you can for that baby. Now, let's try putting ports into a VLAN that doesn't exist yet and see what happens. First, though, remember that from your NA studies? That's one of the 2 commands that you need to statically assign a port to a VLAN. And you'll notice it doesn't even mention the word VLAN. What we're doing here is making sure that the port is an access port, because it could be what we call a trunk port, and we have a section on all of these modes coming up later in the course. We'll go over them all in detail. But a trunk port, by default, is a member of all VLANs, and we don't want that. What we want is a port that is a member of one and only one VLAN, and that is an access port. Now, that's fine and dandy, but now we need to tell the port which VLAN it belongs to, because here we're creating static VLANs, and that comes down to the configuration on the port itself. You want to use the switch port access command then. Then you'll notice it says VLAN, that's our only option, and the description is set VLAN when interface is in access mode. So you need to put it in access mode first. Then VLAN, and then the number. And you'll notice it does have here an option for dynamic. When in access mode, this interface's VLAN is controlled by VMPS. Actually pronounced VMPS. Do not pronounce it VMPS. People will laugh. So we'll talk about VMPS in the very next video. I'm going to fill you in, give you a little more information than you need for the switch exam, actually. But it's good info for you to have. But right now, we just want to put this port into VLAN 12. And that's the end of our options. We see the CR, carriage return. We know that we don't have any options left. And that's it. And we get a little message immediately that says that access VLAN doesn't exist. But the next part of the message is the best part, creating VLAN 12. So if you try to put a port into a VLAN that does not yet exist, the Cisco switch will create it for you. That's pretty sweet. We'll take that. Now let's go ahead and put port 2 in there. Same 2 commands. Actually, I can up arrow to repeat my last couple of commands. If you're learning the commands for the first time, what I always do is I do type them out. But if they're commands you're familiar with, go ahead and use that up arrow. It does save you a little time, and if you hate to type, you'll like it even more. So what do we do here? Anyone who's ever watched a video of mine knows what we're going to do. We know that everything's fine. We trust, but we verify our config always. And what we will do now is run show VLAN brief. And now you see that VLAN 12 has been created. It has a name, VLAN 0012, and the ports, fast 1 and fast 2, are now in that VLAN. So we're good to go there. Looks like everything's fine. Now, before we test that out, I want to show you the other way to create a VLAN, and that is simply with the VLAN command. Now, internal VLANs, don't sweat that. But what we do want to do here is go ahead and say create VLAN 20. And you just created VLAN 20, congratulations. And now we might want to add an option to it or two. And let's take a look at our options. Oh my God! That is a lot of options. The good news is there's really just one, or not even really just one. There's only one that you really need to be concerned with, and that is name. It's certainly not a requirement, but it's kind of like writing remarks and access lists. You know, when I've created videos, training videos for that, I always tell people, please use the remark command because you've got this huge ACL and someone who comes in behind you might not know what it is. If VLAN 12 is your accounting department, name the VLAN accounting. It's just a great organizational tool. And what I'll actually do here is name VLAN 20 accounting. We verify, and let's see what we have now. We've still got our default VLAN. We have VLAN 12, which is named by default VLAN, and then the 4 numbers after it, 0012. We have our 2 ports in there, and we also now have VLAN 20, which is the accounting VLAN. It's empty. We're going to leave the accounting VLAN alone for now. That's what we call foreshadowing. I have a feeling it's going to show up again later, but right now I just want you to see that you can use the VLAN command to create a VLAN, and you can use the name option then to actually name it. As a matter of fact, we'll do VLAN 12, and of course it doesn't give any kind of message creating because it's already created it. And we're going to name that success because that's what we're going to get. And there you go. So we got a little command message there. Let me give it to you clean there. There you go. So you could see that really does help because you're going to have an accounting department and a security department and other departments in there. And naming them really does help out. You don't want to sit there, oh, you know, which one was VLAN 37? You want to say, oh, okay, VLAN 37, that's the trucking department. So, or the trucking VLAN. So we've created VLANs 2 different ways now, and we've named them. And we need to go over and check our connectivity to between our hosts. So let's go back over. Actually, let me show you a diagram here first. This is all the configs that we just did, nothing unusual there. But this is what we have now. We have our 4 hosts that we had. We still have the 1 switch, but we've created another VLAN. And now a broadcast sent by host 1 will only be propagated to host 2, and vice versa. Host 2 sends out a broadcast, only goes to host 1. Just that quickly, you've cut your overall broadcast traffic really by 66%, because your switch was having to copy any incoming broadcast and send 3 of them out. But now, no matter which host actually you choose, 1, 2, 3, or 4, you know, you're in really good shape because now the switch only has to copy the broadcast once and send it out. So let's go ahead and check our connectivity. We'll go back out to host 1 and we'll ping 2, and we're in good shape there. We still have our connectivity. Now we're pinging host 4 from host 1. You know, those dots are never good. They're never good. Let's try 3. This doesn't look good either, because just a few minutes ago, earlier in this very same video, host 1 could ping host 3 and host 4, no problem at all. So what do we always, you know, this is the thing when you have this kind of situation. When suddenly you lose some kind of connectivity, it's related to what you just did. And I know that you're sitting there listening to that saying, duh. But not a lot of people, but some admins, you know, they'll start throwing mud at the wall. Well, no, it's not what I just did. It's what, you know, something else. It's a bug in the iOS. If I hear that one more time. Yeah, it is whatever you just did. So what we just did stops packets going, ping packets going from host 1 to host 3 and 4. And logically speaking, where are hosts 3 and 4 now? as opposed from the viewpoint of host 1, they're in another VLAN. So maybe we're on to something there. Let's go over to host 3. Let's see if I have that connection open. I believe I do. Yep. I'm on host 3 now, and I'm going to ping host 4, the other host in the VLAN. No problem at all. We hadn't sent a ping before, so we lost the first packet, but that's no problem. Now let's try pinging 10.1.1.1. And it doesn't look good. And let's try pinging 10.1.1.2. And that is going to look just as awful. Now, did you notice that the success rate there is 0%? We noticed that part, of course. But it's 0/3. We only sent 3 pings out. Quick reminder, since we like to terminate pings sometimes, especially if we send an extended ping, we could send 100,000 ping packets. We want to be able to stop them. And we have the phrase right here, type escape sequence to abort. It doesn't tell us what the escape sequence is. It's Control-Shift-6 twice, one right after the other. Control-Shift-6, Control-Shift-6, and that will terminate your ping. So now, looking at our network diagram here, we seem to have a problem because while we've limited the propagation of broadcasts in our network, we also seem to have limited the propagation of any kind of traffic, and we definitely don't want that. Right now, we can't send inter-VLAN traffic. Traffic from a host in one VLAN is not going to reach a host in another VLAN, even if they're in the same IP address space, which these certainly are. And they could ping each other 10 minutes ago at the beginning of this video. And that is exactly what the problem is. Now, inter-VLAN traffic is certainly possible. If it wasn't, we wouldn't use VLANs. But it does require the routing layer of the OSI model to get involved. Now, if this were a multi-layer switch, also called a layer 3 switch, I call them L3 switches a lot, but MLS is probably a better term to use, a multi-layer switch. Multi-layer switches are capable of running layer 2 and layer 3 on the same switch. It's really cool. We could enable IP routing on the switch and then work something out as far as routing goes. Now, IP routing is not enabled on a multi-layer switch by default, as we'll see. I've got an entire section for you here in this course doing nothing but multi-layer switching. Now, this is strictly a layer 2 switch. I believe I mentioned that in the previous video. When you're working with a layer 2 switch and inter-VLAN traffic, you have to get a router involved somehow. There's a technique called router on a stick, which is pretty much gone now since multi-layer switching is becoming so commonplace. But you've got to get layer 3 involved one way or the other. That's what I want you to keep in mind right now, because we're going to look at solutions for this situation in the multi-layer switching section of this course. But right now, I just want you to keep in mind that inter-VLAN traffic requires layer 3 to get involved. Because sometimes it does seem like, in networking, we get a solution to something, and then, that solution causes another issue. So while we're limiting the propagation of broadcasts right now, the issue is that we can't have inter-VLAN routing. We can't get packets from a host in one VLAN to another unless we have a multi-layer switch and configure layer 3 on that, or we get a router involved somehow. Now, in the next video, we're going to talk about dynamic VLANs for just a few minutes. I'm going to give you more info than you really need for the switching exam, but it's information you need to know. And also a little real-world tip that has helped me greatly as far as the show VLAN brief command is concerned. So I'll see you on the next video.